Please welcome WCC HTML Activity Lead, Mike Smith.
Hi, everybody. So, my name is Michael Smith. I'm here today to talk a bit about HTML5, but also some things related to HTML5. I couldn't think up a really good title for this, so I went with a boring title. Sorry. Next time I'll be more creative. Speaking of creative, this is my official title. Nanchatte sensei. I don't know what that means, but that Keio University told me that's my official title. So you must call me sensei. You can call me Nanchatte sensei if you want, but you have to call me sensei. Or you can actually also call me HTML5 no tokume kakaricho. Either of those is okay. So actually, if you want to email me, please don't, because I get too much email already. Just kidding about that. If you do want to email me, please do email. If you want to follow me on Twitter, it's Sideshow Barker is my name. Okay, so what I'm here to talk about, the first thing is the HTML5 spec itself. I'm pretty much not going to talk about that at all, because the more exciting stuff that's happening right now that's new, that I think you're going to be interested in as developers, it's stuff that's happening outside of HTML5 but happening elsewhere. So some of that's happening with CSS. There's all kinds of things going on with CSS. CSS is really becoming a more full-featured programming language. So you can do a lot more with CSS now than you could previously. You can do animations, for example. And then speaking of animations, another way that you can now do animations is SVG. I'm not going to talk about SVG at all. But I will be talking about this last bullet point, which is APIs. But before I do that, I want to talk about vertical text. There's a bug that was opened up just maybe less than a week ago. And this is a Webkit bug. And the title of this bug is Implement Block Flow Support for All of Layout. Now, myself not being a CSS developer and not being a browser implementer, I don't know what the hell block flow actually means. But I think this means vertical text support. And the guy who's working on this is David Hyatt, who is the key CSS implementer for the Webkit project. How many people recognize David Hyatt's name? Just, there's one, a few. Okay, so David Hyatt, before he started working on Webkit and Safari, he was working on Mozilla code. And actually, there's a lot of code in, I think, still in the Mozilla code base in their CSS implementation, which Hyatt wrote. and now he's responsible for writing a lot of the CSS code in Safari. Well, why do we care about vertical text support in this bug? Well, first, let me show you this bug. This is a master bug for this feature. And as these kind of bugs go in WebKit, you can see there's a bunch of related bugs. And the fact that they've been crossed out means that Hyatt's already fixed them. And the ones that aren't crossed out are ones that he's still working on. So I would suggest that if you're interested in vertical text, add yourself to the CC for this bug. Why is this important? The market for ebooks in Japan and Taiwan. I've since found out that this is also really important for mainland China. But if you think about the way that you read books in Japan, the novels that you read, a lot of the magazines that you read, they're written with vertical text. And if you want to get an ebook reader, you want to be able to read in the same way you're reading now with printed books. And these ebook readers are basically going to be based on browser engines. Speaking as somebody from the W3C who works on the web platform, we want them to be based on browser engines and on the web platform. And the ebook readers that have vertical text support are going to be the ones that have more market value here in Japan, and in Taiwan, and in mainland China. And there are other ways to publish ebooks. So we want to make sure that our publishing platform, the web platform, also has feature parity with those other platforms for this feature. That's why this is important. Why is this important to you as developers? Well, so I suggest that you start thinking now about the possibility of developing for vertical text use cases. And start thinking about what you can do for ebooks, because the market for ebooks in Japan, and worldwide, but it's going to have huge growth. So there's a lot of money to be made here. There's a lot of cool applications and ebook use cases to deliver for its developers. All right, that's as much as I have to say about that. And I have 36 minutes left, and I'll get to the heart of what I want to talk about. So we're starting a new group, or we have started a new group. It's called Web Notifications. And what this working group is about is it's about giving web applications a way to notify users about changes in the state of the application. The chair of this working group is Anna van Kesteren from Opera. And that's a guy, Anna. He's a guy, not a girl. And the editor is a guy named John Gregg, who I haven't met personally, but he works for Google. John's already produced a spec. And we have a working group for this spec and for this. I meant to say we have a mailing list for this working group. So what am I talking about when I say web notifications? So this is an independent of the operating system API for exposing the platform level or OS level notification mechanisms. To web applications. So let me show you an example if things are working okay for me. I'll get on a Chromium channel where I am. And you see up in the corner there's a notification. That notification is actually coming from Colloquy. So I have two IRC clients open. But I just wanted to show you that. Despite the fact that I was in XChat, my other IRC client, and Colloquy was in the background, Colloquy was able to send a notification that appears on top of XChat, on top of any application. That's an operating system notification. That's not a notification that's occurring only within Colloquy, that's occurring at the operating system level. So Colloquy is a native application, so it can do that because it has access to the platform APIs. But we want to expose this to web applications. So if you're developing a web-based email client, a web-based IM client, a web-based auction site, then this is a way that you can have real-time notifications sent from your web application to the operating system. And of course, the nature of the notifications depends on the platform. On Mac OS, what you'll get is probably a growl notification. And then on Windows, you'll get a whatever it is that the Windows makes. But the other thing is this can work on mobile operating systems too. So, you can set a message waiting indicator, whatever works on the device. This is the interface. So this is just the IDL. This is straight from the spec. The interface is called notification. Has two methods, show, cancel. It has some attributes that are writable. You can see these are event handler attributes. So it's pretty straightforward, simple interface. This is another thing called Notification Center interface. And if you think about notifications, the reason why this is important is because you do not want any arbitrary web application to automatically be able to send notifications to the user, and for the user not to be able to cancel those or block them. You can imagine that if this notification thing gets out of hand, it just becomes a great way for websites to spam users. With, ads and whatever else. So this provides a way to programmatically get access to the permission information that the user has granted to your application. This is a code example of how you actually create and display a notification. What you can see there is you have, in this case, and this API is not final, it might change. But we're creating a notification here that has two parameters. It has a URI for an image file, and then a string. So the behavior of the notification would be it would display a notification with that text and with that image somewhere next to it. Then you can see you set a timer, and after that timer expires, then the notification goes away. The second example here is just a way where you can set behavior related to whether to continuously display subsequent notifications, or whether to quit displaying them after the user has canceled the first one. And that really is about it. That's most of the API that you would ever really want to use in the majority use cases. So very simple. We have another working group which is working on something a little more complicated. This group's called Web Performance Working Group. We have 2 chairs for that working group. One from Google, one from Microsoft. And we have an editor who's from Google. And the draft that he's working on, the URL says web timing. And but the actual spec has been changed to be called navigation timing. What is navigation timing? So we have a problem, which is that current JavaScript-based mechanisms cannot provide you, as a developer, with end-to-end user latency data about the behavior of your applications. So, what are we doing to fix that? Well, we're providing a mechanism that will allow your JavaScript application. Well, let me put it this way. It exposes timing information to your JavaScript application that is not exposed to your application now. And this data is data about perceived page load time. And so this is not just about the network latency, which we can already get some data about. It's about the behavior of the application once it's downloaded to your browser and it's executing within the browser on the client side. So the browser, as it's executing the application, has this data. It's just not being exposed to you as a developer. So we're fixing that. So I think this is actually not the complete list of attributes that are in this interface. But you can see it's a lot of them. First thing you'll notice is these are all read-only attributes. Because you don't want to write any of these. These are informational pieces of data that come back from the browser. And a lot of these are just self-explanatory if you look at the names. Here's another example. Well, not an example. This is the other interface that's related to this, which is notification info. Again, you have some constants here, and you have some read-only attributes. And you have one more piece here, which is this window performance timing attribute. which wraps these things together. So what does it look like when you put it all together as a code example? So you create an object T, which is a performance timing. Another one, which is this navigation. Check the attribute on the timing. This load end attribute, which means, okay, the page is loaded. I don't know exactly what the value is. I would have to go back and look at it load in, whether it's just 0 or 1, but you get the idea. And what do? Well, you examine the load in. Oh, so the load in is a time, clearly, we see now. So you take the load in time, take the difference between that and whatever time was set for navigation start. And then you can, there's one other conditional there, obviously, and then you just, in this case, it just shows it as an alert. This is obviously not something that you would want to do in a real application, is tell the user every time with an alert how long it took the page to load. But I think you can see what else you could do with this as a developer. This is pretty much data that you're not going to want to, in most cases, expose to your end users. It's going to be data for you yourself as a developer. So from an end user point of view, this is really boring stuff. But from a developer point of view, it's very exciting, because it'll help you be able to tune the performance of your applications. So that is what I have to say today about web performance. Now, probably the most exciting thing that I personally have taken an interest in over the last 6 months since I talked at DevFest is this web audio incubator group that we started. What this is about is providing programmatic means to read and write raw audio data. So right now, what an incubator group is at W3C is they're exploratory groups. So an incubator group can't actually publish any specifications. They can only do exploration, and then we have to start a real working group. So we're soon going to be starting a real working group for this because we're pretty far along in the work. So what is this? Well, web audio APIs. So we had, before we even started this incubator group, we had 2 draft specifications. Or actually, we had 2 implementations in browsers of experimental APIs from both Google and from Mozilla. The Google API is in the Chrome beta dev channel builds. Actually, it's not. It's in the trunk, but in order to actually build it into a working Chrome WebKit backend, you have to build it yourself and set some compile time options. So this is not something that most people are going to do unless they're used to building WebKit in your own workspace. But I do have a binary today that I can show some short demos from that Chris Rogers told me this morning was available. So now the Mozilla API is already enabled in Firefox 4 beta. So I know I said that twice, but these are the URLs where you can get information about both of these APIs. The first one is, of course, the Chromium API. And that's a full spec, actually. It's all specced out. The Mozilla document at that URL is not a complete spec. But it's enough that you can actually figure out how to use the API. All right, here's examples coded, well, the actual interfaces. So these interfaces are not for exactly the same purpose, but they're for the same general set of use cases. And you can see here's the interface. This is event. Actually, the first one is just the event itself. And then what we have are some additions to the existing interface for the HTML media element. And you can see that these are prefixed with Moz. The event's prefixed with NS, NSI, I guess, which is Netscape, apparently. And then you can see there's these additions also to the audio element interface. And these are the basic pieces of the Mozilla API. And here's an example of how to use it. So you could use this now. If you actually, while you're sitting here, take this, put it into a page, and run it in Firefox 4. You know, obviously you're going to have to change the address of the audio file. But you should be able to get something going with this because it's already enabled. So what you can see is, you know, you have an ID on your audio element. You get that element, and you just start calling methods on that element. You add an event listener, and with some certain parameters, and then you get going with audio. Here's an example of writing an audio stream. So you instantiate a new element, a new audio, sorry, not element, but an audio object. This is for output. You, okay, this is, I don't know enough about the interface, but apparently you have to set up the number of channels and then a frequency. Then you take this big-ass array, and then you just feed that array to your audio object, and you're now playing sampled audio. This is using, by the way, a typed array, which is not part of JavaScript yet, but it was originally added for WebGL, because as you may or may not know, there's no way currently natively of representing binary data types in JavaScript. You have to use strings and arrays, normal arrays, and it's just very inefficient. So we need a real binary data type, and that's what this is using as an example. That's not standard yet, but hopefully we'll get there with that. Fifteen minutes. So this is the Google Audio Node API. So this uses a different conceptual model, slightly, or more than slightly. But you can get an idea from looking at this IDL what it's about a little bit. This is an example of using that. Just create this name function, set up audio context, create a new audio context object. Then you start, you get the idea of the difference in flavors in these two APIs. What you start doing is creating these other objects, the compressor object, gain object. But ultimately what you're doing is you're doing the same thing. You're taking this audio element, which you're getting by, you know, a particular ID, and then you're going to do things with that gain object that you created and with the compressor. The best write-up of this I've seen so far is from a guy named Peter Beverlew. And he wrote up a long piece about this, about how to actually use this API. So I definitely recommend taking a look at that. So here's an example of how to use that API just to play a sound. So you can see you're doing other things here with this context, which you've created. A barking dog, you're adding filters, a panner, doing stuff with the gain. And yeah, that's pretty sort of self-explanatory once you look at it. So these are toy examples. But if you start, if you go to some of these URLs that I have in the slides, now this is the first time I've tried this, so let's keep our fingers crossed and see if it actually works. Yep, so this is a drum machine. I have not even tried this yet, so I'm not sure quite how it works. I don't see any sound there, so let's try the next one. Let's try this. Left, blue, yellow. Right, blue, yellow. Yeah, unfortunately, I didn't build a binary of this myself, and then I got a hold of one of the other Chromium developers on the Chromium channel this morning and said, hey, I need a binary, and I literally downloaded this binary like 2 minutes before I got on stage here. Let's see, maybe this will work. Let's try it. We'll try this last one. I do have some Mozilla examples that I know that do work. We'll wait for that one to load. Well, let me show you this. Turn that down a bit. This is an example of using real-time manipulation of reverb. You can see as I'm turning this down, the reverb's getting less and less. You can mess with the delay. And I have one other example, well, a couple other examples. So let me pause this one actually so I don't got 10 things playing at the same time. Yeah, so there was a delay there. You can see after your pause. This is an example of panning using stereo. And I manipulate this control. Can't tell if it's panning from here, but you should be panning between two different channels. So this is very basic stuff if you have an audio application that's a desktop application. But the thing to remember about this is all being done in web application inside your browser. Now this is kind of like Audio API 101, which is doing visualizations of audio data in real time. And that's what this is. It's just a way of switching among different visualizations. And this is all in real time using this Mozilla API. You get the idea. So, if you are a musician, a DJ, an audio professional of some kind, what this is an opportunity for you to create audio applications and deliver them over the web. Instead of developing applications that users need to download and install, you get all the benefits of developing things on the web, of the application on the web platform, which is you can push out updates to your application, you can fix bugs, you can do all this stuff without the users ever needing to know about it. So it's really exciting. Now, the downside of this, the downside is neither of these APIs is going to end up being the standard, quite likely. At this point, both of them are highly experimental. And if you build an application using these APIs, 3 months from now or 6 months from now, your application is going to be obsoleted because we're going to have a standard API that we will be using for this instead. But what you can do now is try out both of these, give some, collect some information yourself, record some information about your experiences with the API, and take that back to the group. I thought I had the URL for our working group homepage, but I do not. But we have a public mailing list, so the place to have discussion about this is on that public mailing list. So try it out and start getting feedback to the working group, to the Chrome developers, and to the Mozilla developers on this stuff. Six minutes. The other exciting thing that's happened in the last 6 months is we have new HTML5 parsers in 2 different browsers. This is something that's not exciting at all to end users. But to developers, it's very exciting. Because what it means is you will have browsers where the DOM parsing behavior is predictable and it's exactly the same, minus some bugs. We do have some differences due to bugs, but we're resolving those bugs. So the first browser to ship with an HTML5 parser was Mozilla. Guy named Henry Sivonen, Finnish guy. And more recently, Adam Barth and Eric Seidel from the Webkit project spent several weeks working on implementing a HTML5 parser for Webkit. And that's now shipping in Chrome Dev Channel and betas and in Webkit nightlies. Yep. And I will, just to mention IE9, IE9 does have a parser that is different from the IE8 parser. It has some features of HTML5. But it does not conform to the spec. So just to make it clear, what I'm talking about when I say the spec is that the HTML5 specification has an algorithm that tells you, given any particular byte stream, this is how you convert it into a DOM. So if you have browsers that implement that parsing algorithm, you will get exactly the same DOM in those two different for those two different browsers. And that includes dealing with weird-ass cases like document write, that are a lot of trouble to deal with from a parsing point of view. So that's parsers. Something that is kind of a little less encouraging right now is that the WebSockets protocol is not stable. So if you have been programming to this protocol thinking that it's locked down, you're going to be disappointed, because the protocol is going to become more complex. And it's going to become complex in a way that's not backward compatible. And hopefully it won't be that more complex and break too much stuff. But it is going to change. That means all of the server libraries that currently have implemented WebSocket support, if you've written a server programming language server-side library to do WebSocket server, that code's going to have to change. The client-side implementations in browsers are going to have to change. So that sucks, but that's what standards are all about. We get standards out early so people can use them and give us feedback, and then we make changes based on that feedback. So Ian Hicksey is no longer the editor for the protocol spec. Another Ian Fetty, who's with the Chrome and Chrome OS, is going to be, well, is the editor for that spec now. And he's a great developer, and so we're looking to him to make sure that that spec does not get out of control for the protocol. Okay, we have a couple other APIs that I want to talk about today, which we don't have a huge amount of implementation support for yet. But if you're an Android developer, this is probably stuff that's going to be of particular interest to you. One of them is the Contacts API. That is a way to give read access to a web application to a user's address book. And since almost all mobile devices have some address book that you use on the device to make your calls and send email and stuff, that's useful really on mobile cases especially. The thing is the media capture API. Since most mobile devices have cameras in them, then this is also something where you would find it extremely useful on a mobile device. And I think I'm out of time. Do I have 2 more minutes? I'll take 2 more minutes while they're waiting to tell me if I can. This is a contact interface, very simple, straightforward. If you look at it, you just got a bunch of attributes that model the information in your user's address book. This is an API example that shows you how to read data from that. You can see it's using callbacks, CB for callback, so it's callback-based interface, which is usually a good way to do file I/O. What you can see is you have a contacts find method here, and you're just looking for somebody named Bob. And I don't know what that returns, but I probably return some kind of some structure which has information about Bob. So really simple. But the point of this is we want to have a standard way of doing this so that you can write an application that will work across devices, across platforms, across browsers. This is not working yet, but it's certainly something that we would like to see implemented in Android. It may be implemented already in Android, for all I know. But you can understand if you're an Android developer, this would be something useful for you to use. There's obviously some privacy and permissions issues here that we need to address. But that's the given with something like this. Last thing, image capture API. This starts with some markup on the input element. Say input accept. That's not an attribute that you normally have on input, but you say accept images. Put an ID on it, on that element. Want to further qualify it, you can say accept images and make the device capture device the camera. This example how to program using this. Get the element. It's got a files array associated with it. You get the first file. And then you start doing whatever you would do with the file once you capture it. And that is the capture API. Now, of course, it's also possible, conceivable, to do this with an audio stream. Instead of saying capture accept image, you would say capture accept audio. And, a device, the microphone on the handset. This is one way of doing this. There's other conceivable ways of doing a capture API. And to some degree, it's arbitrary what it ends up being, but we really do want to have a standard for this. And get it shipping on devices so that you as a developer can develop applications that use this. And then, you know, your end users can have a better user experience of your applications and have cool features. There is one thing, and I'm abusing my time here. The features that have not yet been implemented from HTML5 that are on the top of my personal list to see implemented. HTML5 Forms. This is by far the most important feature for web designers and for average developers from HTML5. Unfortunately, it's only completely implemented at this point in Opera. And I said still like many of the UI parts, but I meant still lack. So we want to get everybody to implement that, and we want to see this shipping in Chrome, see it shipping in Mozilla. Another couple things are the details element. The details element is just a way to show an expandable view, like you have a triangle. When you click on the triangle, it shows you, it expands and shows you some contents. When you click on it again, it collapses and hides those contents. Very simple stuff. You can do this now using jQuery and other libraries. But we want to have this supported natively in the browser so that you don't have to use a library to do it. The last thing I want to mention is HTML5 does have a feature for letting you customize the context menu, which is the menu that displays when you right-click on a page. And we want to see that those things get implemented. I have some examples in my slides. See what you have here is details with a summary. Then some content that displays when the details element is open. It gets hidden when you close it. This is the context menu. You set a context menu attribute on the input element that you want to provide, in this case, a context menu for. You define the menu using an ID and a type equals context. You put some commands within that context menu. And you just associate some functions with those commands. So what happens is when you do the right-click context menu on this element, these two commands display in the context menu. Very useful stuff. And that's it. Please, if you have other questions, I'm going to be at the office hours thing this afternoon. I can't remember exactly what time, but feel free to come by. And email me or hit me on Twitter. Thank you.